All right, sorry about that, guys. I didn't hit record, but I just want to mention that this lesson today is about Hess's law. And the idea is if you can't find the enthalpy, the delta H of a reaction using calorimetry, you can find it using the sum, the addition of all the steps of a reaction. And I showed this graph and I showed, no matter how we get to the reaction, the difference between the reactants and products are the same. That delta H never changes. So today, again, this will only take 15 minutes or so. I'll show you how to do this, and then we'll do some review for your, I keep wanting to say final. It's only February, so I mean to say test, your test on Sunday. I'll talk a little bit more about your test on Sunday too. I have a lecture theater booked, this a gigantic lecture theater. It's not a classroom, so we'll be able to very much socially distance when you guys do your test on Sunday. And I'll talk a little bit more about that at the end of class. So the idea with Hess's law, and again, you did this in your lab last week, is that we can arrange chemical reactions so that any extra chemicals will cancel and we can find the enthalpy of the reaction overall. Any multiplying or dividing or reversing we do, anything basically in simple words, anything we do to the chemical reactions, we also do to delta H. And this will kind of come back for us in chapter 5 when we talk about electrochemistry. So I'm going to show you today 3 problems, 3 questions, and you will definitely, wink, 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 definitely see one of these on your test on Sunday. So part of my review today includes these questions. You will definitely see a Hess's law question on your test. So I'm going to show you 2. I'm going to give you a minute or so to practice one of them. And then when we're finished, those questions, I'll show you another couple questions to study for your test on Sunday. So Hess's law. Find the enthalpy for this reaction. Now, this reaction is carbon disulfide, CS2, plus oxygen produces CO2 and SO2. The key to solve these problems is that you need, and I kind of secretly love these questions because it's like solving a puzzle. The key is you need to rearrange these equations on the bottom so that you get the equation on top. And it might look difficult, but it's actually quite simple. It's a hard thing to teach because it's like solving a puzzle, meaning there's no formula, there's no Q equals MC delta T. It's kind of up to you to figure out this puzzle, but I can give you some hints to solve this. What you do is you look in the question, or you look in the, these guys on the bottom, and try to make them match the equation on top. So what do I mean? Well, look at this chemical here, CS2. Find that chemical in the bottom reaction. So, okay, I'm going to go down. I'm going to find the chemical. Here it is here. There's a problem. In the overall reaction, CS2 is a reactant. In the questions on the bottom, or the equations on the bottom, it's a product. So what I'm going to do is flip this. Now, what do I mean by flip? By flip, I mean the reactants and products switch sides. The problem, or the thing I need to consider is if I flip this equation, I also flip this sign. And a flip is a weird word. Again, flip, what I mean is I reverse the equation. The products and reactants switch, which means this sign also switches. And sorry, just let me check the chat here. I got a message. Yeah, exactly. So Ahmed, perfect. It becomes negative 87.9, which I'll show you on the next slide. Okay, let's look at some other chemicals. I have a hint. Hint is normally leave oxygen out of this process. Oxygen, the reason I'm leaving oxygen out of this process is I see oxygen in my equations 2 times. That's going to be very hard to match. So I'm going to leave oxygen out of this. Okay, so let's look at CO2. CO2 is a reactant. Well, it's a reactant here, so I don't need to do anything to CO2. SO2 is sorry, I misspoke earlier. CO2 is a product, so I don't need to do anything to it. SO2 is also a product, which is fine, but there's a problem. SO2 has a 2 in front of it. So I'm going to have to multiply this equation by 2. Again, the goal is to get all of your reactions to match the overall reaction. The cool thing, somebody just raised their hand, just 1 second. The cool,
Yeah, sir. So should we multiply the delta H also with 2?
yes, exactly. Exactly, and I'll get to that in a second. The cool thing about this type of question is there's really no reason to, and this is going to sound weird, but there's no reason to get this wrong, because once I do these things to my equations on the bottom, I can prove to myself that it equals the overall. And as I guess it was Aisha Noren who just said this, yes, because I'm multiplying this by 2, because I have a 2 here, I also multiply my enthalpy by 2. And again, if this doesn't make sense, I'm going to show you another practice problem. Okay, so what does this look like? Well, on the next slide, I'll show you what happens. So the first equation, I'm going to leave normal. It's okay, everything matches. The second equation, I'm going to multiply everything by 2. And the third equation, I'm going to flip, meaning I'm going to switch the reactants and products. Okay, so what does that look like? It looks like this. So the first equation, everything stays the same. The second equation, I multiply by 2. And the third equation, I flip. So I multiply my enthalpy by 2 here. I flip this enthalpy here. And again, by flip, as Ahmed said in the chat, flipping just means I change the sign of the enthalpy. And then I can check my answer.
Sir, when you flip, do you change the equation or only the sign?
Both. So when you flip, you change their equation by switching the reactants and products. So if you look at, let me get my highlighter here. If you look at this equation compared to the original question, I have flipped it. So I had CS2 as a product and carbon and 2 sulfurs as a reactant. And here I flipped it. So the reactants and products switch sides. Now, this is my favorite part of the whole question. Sorry, I just had to take a drink there. You can test this. You can see if you're correct. So how does this work? How do you see if you got Hess's law correct? And again, this is like my favorite part of this question, because when you're doing this on a test, you can prove to yourself that you got this question right. My goal is when I add up all of these equations, I'm going to get my overall. Now, one thing that's important, any chemicals that appear on the left and right cancel, meaning sulfur, for example, because it's a reactant and a product, it cancels. Carbon, because it's a reactant and a product, it cancels. So if something appears on the reactant side and the product side, they cancel out. And then you add up what's left. So what's left? Well, I have one CS2. I have oxygen 3 times, 1, 2, 3. I have carbon dioxide as a product, and I have 2 SO2 as a reactant. This you guys do not need to show on a test or final exam, but this proves to me that my rearranging of the equations worked. I got the correct answer. So then I just add up these numbers. And there you go. There's your final answer. Again, I just added up the numbers on my calculator. Use your negative button on your calculator if you have negative numbers. What I mean by that is watch out for integers. So I have negative 393 plus negative 593 plus negative 87. And when you add up all of those using your calculator, don't forget your calculators on Sunday when you do your test. You can't use your phones. But when I add up all those numbers, I get my answer. So if that was confusing, let me show you another one. I'm going to show you another, and then I'm going to ask you guys to try one. And then this one's a little tricky actually, but I'm going to see if you guys can try that. And then we'll do some practice. I'll show you at least 2 other questions to study. So let's look at this one.
Sir,
Yes?
for the final answer, do we have to look for the significant figures?
No, don't worry about significant figures. I mentioned this in a couple classes earlier. Significant figures will matter in your labs, but for your test, I don't care. I'm not going to mark for significant figures.
Okay, sir.
Perfect.
Thank you.
No problem. Okay, so let's look at this question. Now, the first thing for this question, guys, is oxygen. Never try to deal with oxygen. The reason you can ignore oxygen is because it's in multiple equations, and you're never going to get this balanced if you worry about oxygen. So again, my hint still stands. Don't worry about oxygen. Forget about it. Balance the other chemicals. Okay, so I don't care about oxygen. I'm going to try and balance or solve for NH3, NO, and water. All right, so let me check the chat, and then I'll start with NH3. Aisha has a question in the chat. So the canceling of certain elements will not affect H. That is correct. By canceling elements, it will have no effect on H or enthalpy. Okay, so hopefully, guys, this practice problem will make a bit more sense for you. This is a hard topic. Well, it's not that it's hard to teach because there's no formula. I can't show you Q equals MC delta T. This is like solving a puzzle. This is like teaching someone how to do a Sudoku or a crossword puzzle. The only thing I can tell you is the method for solving the puzzle. The method for solving the puzzle is you can flip reactions and you can multiply reactions. That's it. You can flip and multiply. So let's look at, well, first of all, I have 3 messages in the chat. Hold on. Oh, yep. So Aaron is giving me some answers. I love it. And so is Ahmed. So I know I just quickly read that. I know Ahmed is getting the first one correct. I want to look at the NH3. So let me get my highlighter here. So NH3. Well, I can see NH3 in the reaction below. There's two problems with the NH3. It's on the wrong side, and it only has a 2 in front of it. So what I'm going to do, just like I think Aaron and Ahmed said, is I'm going to flip this reaction, and I'm going to multiply it by 2. And I do the same thing with the delta H. So the delta H becomes positive, and I'm going to multiply it by 2. Okay, so NH3, halas, we have solved it. What about the NO? So let me get my highlighter again. I'll pick a different color. Let's go orange. The NO, it's on the correct side. It is a product, but it's not big enough. I need to multiply it by 2. So I'm going to multiply this equation by 2, which means I also multiply the delta H by 2. Excuse me. And then the water. I'm using all my colors here today. Let's go with baby blue. So what about the water?
Multiply by 3.
Yeah, exactly. Multiply by 3. It's on the correct side. It is a product, but I want to multiply it by 3. And that's it. I'm done.
Sir, so do we multiply the whole reaction, right?
Yeah. Yep. You multiply the top reaction by 2. You multiply the bottom reaction by 3. And the middle one, you're going to flip the sign and multiply by 2. So I take out my old trusty calculator, aka my cell phone. Now, don't forget, you can't use your cell phones in your tests, so make sure you bring your calculators on Sunday. So let's see what I get. Okay, I'm going to try this on my phone. We'll see if I can get the right answer. My phone is horrible for doing this type of stuff. 91.8. Sorry, I'm talking to myself. Maybe you guys can check my answer, because I don't feel too comfortable about it. I'm getting negative 1,600. Let me just try that again. So maybe that is correct, actually.
Yeah, sir, I got same answer. Minus 1628.2.
All right, perfect. So let me just do that again. I didn't trust my phone. I should have trusted my phone. Plus 91.8. Yeah, I got the same answer twice. So when I do this calculation, my delta H, I get negative 1628.2 kilojoules per mole. There we go. Again, do not bring your cell phones to the test on Sunday. You definitely want to bring a calculator. Well, personally, I only own one calculator. And with COVID, we don't want to be sharing calculators. You guys in your test on Sunday will be very much socially distanced. You'll be spread out through an entire lecture theater. I mean, like, this is a room that could fit 200 people, and there's only 30 of us. So you'll be very socially distanced, but we can't share things like calculators. So please bring your calculators on Sunday. So this brings me to this last question. Don't let the fraction here scare you. Remember, don't try and balance oxygen. What I want you to balance is the carbon, the hydrogen, and the methane. And I'm going to give you 3 minutes for this. We'll check your answer, and then I'll go through some practice problems for your test on Sunday. So,
Sir,
yes?
in the previous equation, why did we ignore the oxygen?
You always ignore oxygen. Always.
Okay.
Yeah, do not try to balance oxygen. Always ignore it. So don't worry about the oxygen here. What you really need to look for is the carbon. So try and balance him. That looks pretty easy. I won't say much about that. Balance your hydrogen. And balance your methane. This one's pretty easy, actually. This one's easier than it looks. So guys, I'll be back in 3 minutes. I'm going to give you a minute or a couple of minutes to try this. This is definitely, wink, 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 definitely a question on your test on Sunday, 100%. This is one of the last questions on your test. So I'll be back in 2 minutes.